Hello and welcome to the Unit 4 Section 2 video on triangle inequalities. So we have been talking a little bit about triangles. We got a little introduction to them in the last section. Now we're going to talk about how we can compare different sides and angles to a triangle. So we're going to start off by talking about the positioning of where the shortest sides are in relation to the smallest angles and things like that. So the triangle longer side theorem states that if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So here we have in the triangle that you have pictured here, we have that the larger angle is opposite the longer side. So here in ABC, in triangle ABC, if AB is greater than BC, then we know that the measure of angle C is greater than the measure of angle A. Because if AB is longer than BC, then the opposite angle of AB, which is C, has to be bigger than the opposite angle from BC, which is A. The triangle larger angle theorem states that if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So here, if we say that in triangle XYZ, if we say that if the measure of angle Z is greater than the measure of angle Y, then the side that is opposite Z, which is XY, has to be greater than the side opposite Y, which is XZ. So, I think this makes a little bit more sense if we use an example. So in example 1, we want to list the angles of QRS from least to greatest. Well, the smallest side is QS, so we'll order these first. QS is less than QR, which is less than RS. Okay, so now the angle that's opposite QS is angle R. The one that's opposite QR is angle S. And the one that's opposite RS is angle Q. So therefore, angle R is less than angle S, which is less than angle Q. So we have it from least to greatest. In example 2, we want to list the sides of LMN, triangle LMN, from the greatest to least. So let's start with the biggest. Well, first of all, we need to find out what the third angle measure is. Well, we know from the triangle sum theorem that the sum of a triangle's angles is 180 degrees. So if we subtract 74 from 180, and we also subtract 34 from that 180 as well, we find that the third angle is measured 72 degrees. So knowing that, we can list the angles from greatest to least. So we have angle N is greater than angle M, which is greater than angle L. Well, the side that's opposite angle N is ML, which is greater than NL, which is greater than NM, or MN. So now we have our sides listed in order from greatest to least. Let's list the sides of JKL from greatest to least. Well, we know this is 90, and we know this is 29, so therefore, again, utilizing the triangle sum theorem, we are going to take 180, and we're going to subtract 29 from it, and we're also going to subtract that 90-degree angle from it. And that gives us angle L being 61 degrees. So we're going to go from greatest to least. Well, angle K is going to be the biggest angle. Angle L is the second biggest, followed by angle J. So now we just look for the opposite sides from those angles. The side opposite from K is JL. The side opposite from L is JK. And the side opposite from J is LK. So those are our sides from greatest to least. All right. Now let's talk about the triangle inequality theorem. A triangle is formed by three segments, but not every set of three segments can form a triangle. So for example, segments with lengths of 7, 4, and 4 can form a triangle. But the segments with lengths of 7, 3, and 3 cannot form a triangle, because no matter how you twist those three sides, one of these sides at the very least is going to come up short. A certain relationship must exist among the lengths of the three segments in order for them to form a triangle, and that is the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we can say for this triangle that AB plus BC is greater than AC. We can also say that BC plus AC is greater than AB. We can also say AC plus AB is greater than BC. All three inequalities must be true for you to have a triangle. So in other words, these two sides have to be larger than this side. These two sides have to be larger than this side, and these two sides have to be larger than this side. That is the only way we can get a triangle to form. So in example 4, we're going to determine if a triangle can have the sides of the following lengths. So for this one, we'll start off with 10 plus 4. Well, that's obviously going to be greater than 8. So that one checks. How about 4 plus 8? Is that greater than 10? Well, 12 is greater than 10. So that checks. And what about 10 plus 8? Is that greater than 4? Well, obviously it is. So that checks. So yes, we do have a triangle. All right, for B, 12 plus 6 is greater than 8. Well, that's obvious because 18 is greater than 8. So that checks. How about 6 plus 8? Is that greater than 6, or I should say 12? Well, let's see. 6 plus 8 is 14, so yes, that is greater than 12, so that checks. What about 12 plus 8? Well, that's going to be greater than 6, and 20 is greater than 6, so that checks. So yes, this is also a triangle. Let's check out C. Is 21 plus 6 greater than 14? Well, 21 is already greater than 14, so adding 6 is certainly going to make it greater than 14, so that checks. All right, how about 21 plus 14? Again, that is going to be greater than 6. We've got 35, so that checks. How about 6 plus 14? Is that greater than 21? Well, 6 plus 14 gives us 20, and 20 is not greater than 21. So that one does not check, so therefore, those three side lengths cannot give you a triangle. The triangle inequality theorem cannot be used to find the exact length of a missing side of a triangle, but it can help determine a range of the possible side lengths for a missing side. So here's the theorem for you, or at least here's the definition that you can use to do that. But it makes more sense when we do it in practice. So let's do that here. So for example 5, we're going to use the triangle inequality theorem to find the range of possible x values. So what we're going to do is, since we don't know this side, we're going to do 16 minus 10. It's going to be less than x, which is going to be less than 16 plus 10. So 16 minus 10 gives you 6. 16 plus 10 gives you 26. So x can be anywhere between 6 and 26 and make a triangle. For this one, we're going to do 9 minus 8 is less than x, which is less than 9 plus 8. 9 minus 8 is 1, and 9 plus 8 is 17. So x can be any value between 1 and 17 to make a triangle. And then finally for C, we got 21 minus 17 is less than x, which is less than 21 plus 17. So that gives us 4 is less than x, which is less than 38. So x can be anywhere between 4 and 38. So this brings us to the Hinge theorem. The side lengths and angle measures can be ordered between two triangles using this theorem. Now, you're going to look at this definition or this theorem, and it's going to sound like a lot of mumbo jumbo. Here's the bottom line of what the Hinge theorem states. If I have an angle A, it can be between two congruent sides and be a smaller angle, and we still end up with a different triangle, okay? So we can have two sides be congruent, but the third side can be a different length and give us a different angle opposite of it. The inverse of the Hinge theorem also holds true, that if we have two side lengths that are different, the other two sides can be the same, and that changes our angle measure that's opposite of it. Okay? So you can think of this as a hinge. As this thing closes, the side length gets shorter. As it closes, the angle also gets smaller. So let's do some examples utilizing this. We are going to compare the measure of angle POM and the measure of angle NMO. And we're going to figure out which one's bigger and which one's smaller. Well, we have a congruent side here, and then this is going to be congruent to itself. With that in mind, we can take these two different sides and the sizes of them and compare them to the opposite angle. Okay? So, NMO has the larger side opposite of it, so it's going to be bigger. So that means POM will be smaller. So the measure of POM is going to be less than the measure of angle NMO. Let's look at another example. We're going to compare the sides QS and TS. Well, we're told this side and this side are congruent, okay? So, going opposite here and opposite here, 45 is the bigger angle, 43 is the smaller angle. So, QS, being opposite the bigger angle, is going to be greater than TS, which is opposite the smaller angle. In example 8, we're going to compare PQS, which is here, and RQS, which is here. Well, these are congruent because they're both measure 7, and these are congruent. So here's our hinge. If we go opposite, then we find that the PQS is larger, so because it's opposite the larger side. So the measure of PQS is going to be greater than the measure of RQS. In example 9, we are told that this side and this side are congruent. We know this side is congruent with itself. And so KL is opposite the smaller side, or the smaller angle. So KL is less than MN. And then finally, for number 10, we're going to find the range of values for Z. We know that this and this are congruent. We know this is congruent with itself. So this is opposite the smaller side than this. So therefore, we can say that 6Z minus 3 is going to be less than 45. We can also say that 6Z minus 3 is going to be greater than 0 because this angle measure has to be bigger than 0. If it's 0, we don't have an angle. So if we add 3 to both sides, or all three sides, we get 3 is less than 6Z, which is less than 48. And then we divide each side by 6. We get 1/2 is less than Z, which is less than 8. And so our range of values for Z are anywhere between 1/2 and 8. All right, that wraps up section 2 of Unit 4. Coming up in section 3, we're going to talk about transformations and triangle congruence.